All right, everybody. Thanks for joining in. Today, we are going to discuss charge, discharge, and state of charge during this IQ installer training. And really, state of charge is what I'd say I get the most questions around. It's probably our top FAQ. So I'm really excited to talk about this today, and I hope that you're all going to take something away from this. I want to get started with just a little bit of housekeeping. If you have any questions, or if there's something important you want to point out to everybody, please just type it in the Q&A section. It's either going to be at the little bar at the top or bottom of your screen. I'm going to get to all those questions and comments either at the very end if I haven't answered them during the presentation. There will be NABCEP credits available for this presentation. So if you need them, just stick around to the end. I'm going to display my email at the end, and just shoot me an email with your full name and I'll send you a NABCEP credit for this training. Let's see, anything else before we get started? I think that's all for today. This should be a pretty fun one, so I'll go ahead and jump right in. Today, I'm going to get started, as usual, with an overview of our company as well as the history. So for a timeline of our growth, we were actually founded in 2010 as OES Energy. So we're now leveraging over a decade of experience in the lithium battery industry. Now, we were actually founded to solve a big problem, and that is unsafe lithium batteries. Now, at the time and still today, there are tons of issues around safety with lithium batteries, like thermal runaway and even having lithium batteries cause fires. So we were founded specifically to solve that problem in the mobile industry. We were at the time making power packs for Hollywood filmmakers to use when they had, their mobile camera gear and their filming equipment and all that stuff. So we very quickly, though, moved into military applications. Now, this is a really big one here because the military at the time didn't even want to use lithium batteries due to all the safety concerns around thermal runaway and fire that can occur. However, we were able to even prove to them that they were safe enough. So we basically said, hey, why don't you just take some to Aberdeen Proving Grounds and test them out? See if they meet the safety standards that you're going for. And we were actually able to convince them that these lithium iron phosphate batteries that we were selling were safe enough for their projects, even though they didn't want lithium batteries. So that was a real breakthrough for lithium batteries in general and our company as well. But we didn't stop there. We continued to emerge into residential as well as emergency response. So in 2013, we began expanding our product line, really focusing on the installer and the customer here. You can see this power bank on wheels, super customer friendly, really nice product. We still have something similar in our lineup today. Now in 2015 and 16, we actually relaunched as SimpliPhi Power. And now starting in 2017 and continuing to today, we've been ramping up manufacturing at our Ventura County, California location. So we're still expanding our product line and expanding our manufacturing capacity. Now, as I mentioned, we use lithium iron phosphate because it is the safest lithium chemistry. It's also, on a side note, the most environmentally friendly. Even though that's a general term for now, you'll have to take my word for it and watch some of our other trainings that detail why it's so environmentally friendly. To build the battery, though, we use lithium iron phosphate and then cylindrical form factor. So cylindrical form factor is going to be the most durable, least prone to puncture or short circuit, and it's going to have just the best performance and longest lifespan as far as cycle life goes. Pouch cells, on the other hand, are a little bit more prone to puncture and swelling during different temperatures or temperature fluctuations or mobile situations. If it's moving around a lot, pouch cells just aren't a great bet. And prismatic cells are awesome. They're just a bit too bulky. So as I mentioned, we were founded to solve a problem, and that was unsafe lithium chemistries. However, this problem has since grown into a limited access to safe, reliable, affordable, and sustainable power. Now, the demand is coming from escalating energy costs, failing infrastructure, and the growing demand for decarbonization. So energy costs are rising not only in the US, but all over the world. Our infrastructure is really just not designed to handle today's technology. Let's look at transformers as just one example of a piece of equipment that's installed purposefully undersized by the utility to save money and overloaded during the day and run at less than full capacity at night and allowed to cool down. Now, this worked really well for quite some time. But now with the addition of EVs, they're not cooling down at night. They're staying overloaded 24/7 and they're getting destroyed. So our grid is just not designed for today's technology. And really the solution for that is distributed assets. That's what we're trying to bring to people, is control over their power by allowing them to use distributed assets. Additionally, the need for decarbonization is growing. More and more cities and states and even utilities are calling out that they are going to meet a specific clean energy goal. Some of them are going net zero carbon, for example. That's what my county here in San Luis Obispo has done. And they just often lack a clear plan of how to meet those goals. So that's where we come in with the solution. Now, our batteries are used in a variety of applications, such as peak shaving, time of use rates, and integrated solar and storage. Now, I'm going to start with peak shaving. Of course, you can use batteries to meet a power demand over a certain amount at any one time, and that's going to prevent a really excessive charge on your bill. Time of use rates, if you have batteries, you can just buy power when it's the cheapest and then use it whenever you want, instead of having to worry about only buying power when it's cheap and really conserving at night. Like, oh no, what if you have to take a shower between noon and 6? Maybe that's going to cost you $10. Just don't worry about it if you have batteries. Integrated solar plus storage, we all know this, but PV is produced in the afternoon really and the morning, whereas you're really using power before and after work when the sun is not even really out. So if you want to use your own PV power or live off grid, you really need batteries. Additionally, a lot of people don't realize that if they have a solar system but no batteries, then their power is going to go out as soon as the grid goes down. This, solar array that you have isn't going to stay running without batteries. I do see a raised hand. I just want to let you know that I can't unmute you, so please just type your question into the Q&A bar as it comes up. I'd be happy to get to those as soon as I can. Cool, so let's jump into an overview of our products. And this is going to be just a couple-minute overview of our products, and then we're going to get into the charge, discharge, and state of charge section, really the meat of the webinar. Cool, so our Phi battery. This is a 3.8 kilowatt hour battery, 150 amp hours at 24 volts or 75 amp hours at 48 volts. It's made for a simple parallel connection. So this is not to be put in series. If you need a higher voltage product, we do offer that, but I'm not going to cover it today because it's just not really central to this webinar. Now, this battery is modular and scalable. And what I mean by this is, first off, it's less than 80 pounds. So one person can bring in as many of these as they need to a job site to build a giant system. And by scalable, I mean quite literally there is no limit to how many of these you want to parallel. We've seen system sizes over 300 kilowatt hours with this battery, which is kind of crazy. And there's some creative wiring methods you can use to parallel that many batteries. Now, this was originally designed as a drop-in lead acid replacement, but it's being used for all sorts of things now. And it comes with an integrated BMS that's internal to the battery that provides some protection, as well as an integrated circuit breaker for not only protection, but also easy installation. I find it really helpful to have a circuit breaker right on top of the battery to just make it not live when I'm installing it. Our 12-volt battery, this is also going to have an integrated BMS internal to the battery. Now, instead of the 3/8 inch studs on the other battery, this battery actually comes with an Anderson connector or bare wire. So this is going to be better suited for smaller systems or mobile applications. It comes in 12 volts or 24 volts at 1.4 kilowatt hours. And this battery weighs only 33 pounds. Now, just like our Phi battery or 3.8 kilowatt hour battery, this is compatible with a wide range of charge controllers and inverters. And you can really use any equipment you want as long as it meets the charging set points and low battery cutout that's needed for our batteries. And those are clearly laid out on our support tab of our website. But we're going to get to them today as well. Our access unit, this is really growing in popularity right now. It's a plug and play solution. So it comes pre-wired and the inverter comes mounted inside of the cabinet. Crated delivery. This is a NEMA 3R enclosure, so it's ready to sit outside. And it comes in AC or DC couple options. We have an option with the SolarArc inverter and an option with Schneider inverters. This is going to be great for not only existing PV, but even new systems if you want. I find it exceptional for an AC coupled system because you can just basically drop it right in between your sub panel and your main panel. And all that equipment's already outdoors, so this makes your install a bit easier being able to use it outside. And of course, can't forget our newest battery, the SimpliPhi battery. A nice, beautiful white case is the first thing you'll notice. A metal case that's going to add a couple of pounds to this battery, making it 86 pounds, but not changing its dimensions. So this battery can still fit within all the same enclosures, access units, boss cabinets, wall brackets, you name it. It's the same outer dimensions as the Phi battery. It is also 3.8 kilowatt hours and 75 amp hours at 48 volts. Now, the main advantage to the SimpliPhi battery is that it's got closed loop communications with inverters. So at the moment, it's only communicating with SolarArc inverters. However, we're really working on this list to expand it to more and more inverters as time goes on. There's no external cards required for this inverter communication. And what the communication is going to do is it's going to allow you to auto-populate set points so that you can do less programming on the inverter, make for a quicker install. It's also going to give you more protection on these batteries. So in a standard Phi system, we're going to talk about the charging and discharging in just a second here, but you're limited to C/2 charging, which really, that's huge already. But with the SimpliPhi battery, it's going to almost protect itself, right? The solar arc inverter, the SimpliPhi is going to tell the solar arc, hey, I only want to be charged and discharged at C/2. And the inverter is going to follow that instruction. If the inverter somehow does not follow that instruction, of course, there's a BMS internal to the battery, but we don't want to rely on that. We just want the BMS to be the last line of protection. Additionally, the SimpliPhi battery is going to report a really highly accurate reading for state of charge to the inverter so that you can monitor your batteries through your inverter's monitoring portal. And it's also going to show you voltage, charge, and discharge at any time. Now, this advanced protection is going to allow you to flexibly size your system. So if you need to get started with just one SimpliPhi battery on a solar 8 kilowatt or 12 kilowatt inverter, you can actually do that with the SimpliPhi. Whereas with the Phi batteries, we would not recommend that at all. Awesome. So now let's jump into the meat, the main course of today's presentation, charging, and then we're going to talk about discharging characteristics, and then state of charge. And of course, we'll wrap up with the Q&A. So as far as charging characteristics go, our batteries are rated at C/2. So this means if you've seen a lead acid battery rated at C/20, this means that they allowed it to discharge slowly over 20 hours to see how much energy they got out of it. Now, if you were to do that with a C/2 discharge on a lead acid battery, you're going to lose probably 30 to 40% of that capacity. But with our batteries, they're actually rated at C/2. That's how we found that 3.8 kilowatt hour value. And additionally, that is the maximum charge and discharge rate that we allow is C/2. So when you're doing a continuous charge, the max current values for all of our Phi batteries are 37.5 amps for the 3.8 kilowatt hour battery, 75 amps for the 24 volt version of that battery, 28.5 amps DC for the 24 volt 1.4 kilowatt hour, and then 40 amps for the 12 volt 1.4 kilowatt hour. Now this is a bit less than C/2, limited by the conductors within the battery to slightly less than the cells can actually handle. But these three batteries, of course, are all rated at C/2 continuous charge and discharge. So one way I like to think about this is if you have a 3.8 kilowatt hour battery, you're going to multiply that by 1/2 to get 1.9 kilowatts is the rate of discharge. Now, another way of thinking about it is if you have a 75 amp hour battery, which is the 3.8 kilowatt 48 volt, it's a 75 amp hour battery, and you can discharge it at 37.5 amps DC. That's half of the 75 amp hours. With the SimpliPhi battery, you still have the same continuous charge and discharge rate, but the battery is able to really tell the inverter to protect it. So you have to keep in mind these are extremely important with the Phi batteries. You need to follow them. With the SimpliPhi, still a limiting factor, but the inverter will actually protect the battery. Now, one thing to keep in mind when you're considering multiple charge sources charging at the same time is this 37.5 amps is the total maximum charge rate. So if you've got a generator running at the same time as your solar panels are charging, it could overcharge the batteries if you don't have them limited correctly. Now, the way to remedy this is to use global charge. On newer equipment, they almost always have this global charge setting. You're going to be able to limit 37.5 amps DC as the maximum amperage DC that you want each battery to see. And even in addition to using the global charge limit, I always recommend putting in a DC fuse or breaker in line. Now we're going to talk a bit more about breaker sizing on a later slide. But I just want to point out that, the BMS is not going to modify the amount of power or voltage going into the battery. It's only going to open or close the circuit. So if you try pumping 50 amps into your 48-volt battery, the BMS, if the BMS, could open circuit in that scenario. You really don't want that to happen, because happening once, it's not that big of a deal, but happening over and over again, you will definitely cause damage to the battery. So again, you want the BMS to be the last line of defense. And you want to program the system correctly to be able to limit that charge current on its own. Now, with a charge controller, limiting the charge rate is extremely easy. You just open up the charge controller or the remote and you program in the value of amps you wanted to pump through at any given time. With an inverter, it's easy to program, but it's questionable as if the inverter will actually follow that limit. And so what I mean by that is if you're charging from the grid and you've programmed it to charge at 30 amps DC, I have no question that the inverter will actually follow that instruction. But if you're AC coupling with a PV array that is too large for the battery bank, and you tell it to, limit the charge rate, I would not rely on that, because it's a very complex technology. It relies on frequency shifting to limit that charge rate. Now, I don't want to go into too much detail as to how frequency shifting works today, but ultimately, frequency shifting is a newer technology, and we have seen issues occur. Now, it gets better and better every year without fail, and I have no doubt that it'll be perfected soon. But for now, I would not rely on it to prevent overcharging in our batteries. What I would do instead is limit your solar panel array to being sized correctly. So if you've got, let's say, 20 kilowatt hours of battery storage, then you need a 10 kilowatt PV array at most. That's half the size of the storage. Now, another thing to think about when you're AC coupling a PV array is, let's just talk about the US Electrical Code for 1 second. So the NEC code 2014 and 2017 require rapid shutdown of a PV array within 10 seconds to be 30 volts or less. So essentially, it's barely producing any power, if at all, within 10 seconds. Now, during those 10 seconds, let's say that the battery bank is already fully charged. And then the energy from the solar panel has nowhere to go because it cannot go to the grid. The grid's already disconnected. So during those 10 seconds, the panels will actually push that power as they're shutting down to the battery bank. Now, if the battery bank is fully charged, that could cause some damage, right? Especially if the array is larger than C/2. So that's why it's so important to have a correctly sized array when you're AC coupling. Now, again, it's not as big of a deal for DC coupling. If you want to have a slightly larger system than C/2 when you're DC coupling and just limit that through the charge controller, that's totally fine, because the charge controller is totally separate from the grid. It doesn't even see the grid, has no idea when the grid is out. There's no 10-second shutdown on a charge controller. So this is why I generally prefer DC coupled systems, but I don't want to go too deep into detail about that today. Just know that when you're AC coupling a PV system, it really needs to be sized properly. I can't stress this enough. Now let's talk about voltage. When you're using a charge controller, for example, you can do 3-stage charging. That's bulk, then absorb, and then float. So let's first talk about bulk and absorb. We call these CC and CV for constant current and then constant voltage. For constant current, you're trying to pump as much current as you can into the batteries, 37.5 amps per 48 volt battery, throughout that whole bulk charging period. And that's where the battery is going to get most of its energy from. Now then, when you transition over to the absorb period, it's almost already fully charged. It just needs a little bit of current tapering off over 6 minutes at 56 volts. So you hold the voltage steady and taper off the current as the battery tops off. So this is almost like filling up a glass of water, right? You want to fill it up fast up to about here, and then you want to slowly fill it up so you don't overfill it. Same thing with batteries. Now, let's also talk about when to use float and when to not use float. Now, as I said, if you're using a PV array, it's great to use float. For example, you can float the batteries at 54 volts and keep them totally full while your excess PV is just powering the loads. This is perfect because you don't want to start drawing from your battery bank when the sun is still out. It doesn't make any sense. But if you're charging from the grid, it really doesn't make any sense to float. If you're charging from any AC source, it actually makes no sense to float, because if you are, let's say, charging from a generator and you want to leave float on, you're running that generator just to power your batteries, just to keep them full. It's such a waste of fuel for your generator. I really just don't see any scenarios where it's beneficial to use float with an AC source. Now, I may have skipped over this. When you're programming for bulk and absorb charging, that bulk charge is going to end at 56 volts. That's where the absorb charge is going to begin, and it's going to last for just 6 minutes. As I mentioned, the battery's already fully charged for the most part when it gets to bulk, so it just needs, or when it gets to absorb, excuse me. So it just needs a couple extra minutes of topping off. Rebulk, this is a setting that you can actually play around with a little bit. Now, most of our guides say to use 51.2 volts. This is great because most of the time you're discharging to 51.2 volts overnight, and then as soon as the sun comes out, your system's going to begin a bulk charge. Now, however, if you want to make sure that your system initiates a bulk charge each morning and you aren't reaching 51.2 volts, you may want to raise that just a little bit. I wouldn't go above 52 volts for a rebulk for your 48 volt battery. And just a quick note on voltages. For all these voltages that I'm reading at 48 volt nominal, just cut them in half. So 56 volts, if you were transitioning that to a 24 volt battery, you'd use 28 volts. So as far as inverter compatibility, it's the same. You want to set the 56 volt bulk and absorb voltage for just 6 minutes. This is really going to give you the fastest charge, as well as the fullest charge, making sure the battery gets completely full. With AC coupling, you really need to make sure it's at 56. Otherwise, the frequency shifting, it's just not going to work as well. And I've never really seen a 24 volt system that was AC coupled. So I don't think that's going to be a concern. A lot of older models of inverters are kind of concerning. So often they are able to meet our set points. I've seen a lot of Schneider Trace inverters, I guess, was bought out by Schneider at some point, but Trace are pretty old inverters, yet they're still able to meet most of our set points. At least most of the Trace inverters are able to meet all of our set points, actually. But, I've seen a few inverters that are maybe 20 years old. Not really remembering the brand at the moment, but if it's either an older inverter or a cheapo inverter, I'd say replace it or give us a call and make sure that we can verify that it meets the needed set points. Especially ask the inverter manufacturer if they warranty for lithium-ion batteries, right? So if their inverter damages your lithium-ion batteries and it's listed in their warranty that they don't cover that, that's going to be a big pain. And really, if they don't warranty for lithium-ion batteries, it's just not designed for lithium batteries in general, and you probably shouldn't be using it for them anyway. So using an external charger, we do have a list of approved chargers you can use if you want to, let's say, pre-charge a battery before installing it. It's not really needed. Or if you were to draw your battery down to where it reached its internal low battery cutout. It doesn't happen often. The only time we really see this happen is if the installer has forgotten to program the low battery cutout value into the inverter. So make sure as you're discharging the battery, as it hits 50 volts is where we recommend that low battery cutout, because the absolute minimum we want the battery to see is 48 volts. And there's a slight delay. So if it reaches 50 volts and then it has a slight delay, it might actually come very close to that 48 volts before the inverter has a chance to disconnect the battery and stop powering the load so your battery doesn't reach internal low battery cutout. You really want to avoid that internal low battery cutout. It's just a pain to have to reset the battery, and then sometimes you do have to use an external charger. So if you run into that scenario, give us a call or an email and we'll help you find a charger that's going to work for you. Sweet. Halfway through, let's talk about discharging. Oh, excuse me. So here is an example of the discharge curve. Now, this is very flat, as you can see, all the way from almost 100% SOC to around 10 or 20% SOC. It's extremely flat, unlike a lot of other battery types. Now, lead acid batteries have a more straight curve. They're going to go from, let's say, 58 all the way down to around 40 volts for 0% state of charge. Other lithium batteries have a slightly wider range sometimes, but they're within this same range for the most part. So as you can see, though, as you get down to 10 or 20% state of charge remaining, the voltage just really drops off. You have this knee here. So it's crucial, I'd say, to have your low battery cutout set at a minimum of 48 volts. Really, we'd like to see it around 50 volts, ideally. To give your inverter some time, as I mentioned during that delay period, to disconnect the battery before it reaches that 48 volts and then abruptly drops off. So this is why you can tell that 48 volts is 0% state of charge, because the voltage just plummets after that. And again, this is at C/2. So this is when the battery is discharging in 2 hours. That's a very fast discharge. In residential systems, you're just not often going to need a C/2 discharge. But we're going to talk about that a little more on these next slides. So just like our C/2 charge rating, our batteries are rated to C/2 discharge as well. So this means that yes, you can discharge your 75 amp hour battery at 37.5 amps DC, same rates as charging. Now, again, the SimpliPhi is going to communicate with the SOLARC to tell it the maximum discharge rate, just as it would for charging, and that's going to allow the SOLARC to better protect the SimpliPhi battery. There is also a surge for discharge. So each 3.8 kilowatt battery excuse me, 3.8 kilowatt hour battery can discharge at 80 amps DC for 10 minutes. The 1.4 kilowatt hour battery can discharge at 60 amps DC for 10 minutes. And our SimpliPhi battery actually has a 100 amp DC breaker, and that can discharge at 100 amps DC for 10 minutes. Now, our batteries are great for a grid-tied backup because often you really want to be using that C/2 charging rate. But I've really never seen any customers need C/2 discharge on a residential application. Now, it is nice, especially if you live off-grid, to be charging at C/2. So if you've got a really nice sunny window, you want to make sure you can pump in as much energy or as much power as you can to save up for those cloudy days, especially if you live in a cloudy place like maybe Washington or Oregon, or even the East Coast, depends where you are. But if you're off grid, the C/2 charging is probably going to be really important to you. And as I mentioned, you can use inline breakers for protection. Let's talk about that in some more detail though. So if you've got an 8 kilowatt inverter, then you actually need 16 kilowatt hours of storage to prevent damage from over discharge. So if you have an 8 kilowatt inverter, it can draw 8 kilowatts from the battery. That means you need 16 kilowatt hours of battery to be able to provide that C/2 rate. Now, a lot of times your customers will say, I really like this inverter. I know it's 8 kilowatts, but I'm never going to use that full 8 kilowatts. And then you leave, and then they add a circuit to their system, and then they turn on all their loads at once, and you're screwed, right? It's foolish to not use some sort of hard protection. You don't want homeowners relying on their memory to limit their loads. And I can't stress this enough. So if you're installing a inverter that's too large for the battery bank, you need to be using breakers and fuses to protect the batteries. This is not foolproof though. It's really the easiest way to prevent over discharge is just by sizing properly. But if you're not going to size properly, make sure to deeply research the breaker size that you need or the fuse size that you need. I actually recommend putting these on either the AC output of the inverter, the main load output, or the DC between the DC bus and the batteries, so that you can limit the total DC charging rate of the bank. And we're going to talk about sizing in a bit as well. So if you've got, let's say, a 8 kilowatt inverter, but you've only got 2 batteries in the bank, those batteries can discharge 37.5 amps DC each, making the total bank able to discharge 75 amps DC. You're going to want probably a 60 amp breaker. And this is just a general rule of thumb. You're going to want to go smaller than the maximum continuous output for the breaker size. Now, you can also limit charge and discharge with you can also use the grid or generator load support feature to limit the discharge that the batteries are going to see. So you can have the generator start when the load is above, let's say, 3 kilowatts, and it's going to support that excess load up to 8 kilowatts, let's say. I don't like relying on this though, because what if you forgot to fuel the generator? Or what if the AGS fails? Or what if your generator takes 10 minutes to start? Who knows? It's just easier to size the system correctly. Now, one more note on breaker sizing. Breakers actually have a time delay, so they're thermal circuit breakers. It's a really simple piece of equipment. When it gets too hot, it opens the circuit, right? So you've got 2 metal plates, one expands, and the circuit opens when it gets hot. Ultimately, the time that takes can greatly vary based on what type of circuit breaker you're using. I really like Blue Sea circuit breakers and fuses because they publish this time delay that they've found. This is when the breaker would trip. So for example, on a 60 amp breaker, 200% of that 60 amp current is going to be 120 amps DC. And it's going to take that breaker 10 seconds to trip. So if you've got 110% of that charge current, then that's going to take the breaker about 500 seconds to trip. So 110% of 60 amps is about 66 amps, and it's going to take it 500 seconds to trip. That's perfect because the batteries can handle, 66 amps for 10 minutes, no problem. That's perfect. Now, when you move on to a different type of breaker, though, that curve changes completely. And really, it's just you need to deeply look into this before you start relying on it for your protection. It's not foolproof. This is another Blue Sea breaker with a totally different trip curve or delay curve, whatever you want to call it. And the fuse, again, a totally different curve for the fuse. I like to think that fuses trip faster than breakers, just from my experience. But, when we go back, I guess it's not all that different. Now, we already talked about the knee a little bit, but I want to highlight how important it is to set your low battery cutoff properly. At 50.2 volts, this is perfect because that's 20% state of charge remaining. And then that delay on the inverter might allow the batteries to continue to discharge for a little while, and they'll probably cut off around 10% state of charge remaining. But if you were to set your low battery cutoff 48 volts, most of the time it works. But if you have a large load and there's a significant delay on the low battery cutout, then you're over the cliff here, and you're going to fall down that waterfall. Your battery's just going to drain, really quickly to a low voltage, and it could experience some damage. Luckily, there is a BMS internal to the battery that's going to protect it. So doing this once or twice, not that big of a deal. But doing this over and over again is going to damage your battery. So you need to be careful to program the low battery cutout. And this is really the main place that we see damage and customer phone calls is when they have forgotten to program the low battery cutout. It's a very simple thing to avoid and very important. So I want to make sure that everybody programs that correctly. You can also program a generator start. So for example, the Magnum inverter has a maximum low battery cutout of 48 volts. That's a little too low in my opinion. But if you've got a generator that can run based on voltage, you've got AGS hooked up, and you make sure that generator is always fueled, then it's not a problem because you can program that generator to start at 50.2 volts. And then you will never run into a scenario where you reach 48 volts with your batteries. So it's really not a problem. As long as you consider this in your system design, you should be fine. So let's also move on and talk about our most frequently asked question, state of charge. How do I figure out what state of charge my battery's at? We will get there. So first, I just want to talk about this chart here. So this is the discharge voltages. So when you're discharging at a C/2 rate, so this is at a high load. Let's say you charge your battery to 100% and you pull it off the charger, or you disconnect the charging source and immediately power a C/2 load. It's going to draw that voltage down to about 50.2 immediately when you turn on that load. Now, if you were not powering a load at all, or you were only powering maybe a 50-watt load, it's going to rest at about 53.3 volts when it's fully charged. So that's when it's not powering a load, or when it's only powering a very small load. I call that a resting state of charge. That means that it's no longer being charged by the power source, and it's either just resting or powering a very, very small load. Excuse me. And again, these values here, they actually were taken in a lab. So this is, laboratory data. It doesn't exactly match real world data. I'll tell you one thing though, 0% state of charge is definitely at 48 volts. You never want to go below 48 volts, no matter what size load you have connected. Okay, so the grand question, how do we know the state of charge percentage? I really like to recommend Victron's BMV712. Now this is a battery monitor that you can actually monitor through your phone through Bluetooth, and it's very accurate as far as state of charge. My guess is that its algorithm relies heavily on the amp hours in and out through that shunt. Now, that is often a lot more accurate because when you're measuring voltage to correspond to state of charge, this is just such a narrow window that there's not a lot of difference here to measure the voltage and know the state of charge, whereas a lead acid battery be such a larger window, up to 58 approximately, and all the way down to 40 approximately for 100 to 0. So really, it's important to use a shunt-based monitor, and the best of those monitors that I found is the Victron BMV712, but there's plenty out there that work well. Now, if you've got a battery monitor that you ordered with your inverter, let's say you got the Connext BMK, we have the settings for those in our integration guides, and you're going to want to make sure you program it to make it the most accurate. So when you can enter in the amp hour capacity of your battery bank, the charge and discharge efficiency of the battery bank, and a few other things. Sometimes they ask for the Puchera exponent and a few other things. Those are all listed in our integration guides. Now, this brings up the rebulk and recharge point. Remember earlier I said that we generally recommend 51.2 volts for rebulk. That's probably around 60% state of charge. This allows your battery to exercise before you start a new charge, so you're not just constantly keeping it full all the time. You're actually getting some use out of it. But you don't have to set the rebulk all the way at 51.2. You can actually set it as high as 52, I'd say, without any issues. And if you are having issues where you feel like you're waking up in the morning and your battery bank is not charging, even though the sun is out and you've used significant capacity, give us a call and we would be happy to review your settings with you and see if there's any changes that we can make to make your system operate a little bit better. Now you're going to want to set your cell voltage around 52.8, so it's always going to sell the most that it can. All right, so I want to briefly touch on our Installer IQ program. This is going to bring a lot of business your way if you're already installing our batteries. It allows you to highlight your projects through our marketing and our newsletters. You're also going to get a spot on our Where to Buy map. So this is going to help homeowners find you if they're looking for an installer, as well as distributors. I see distributors sometimes use this map when they need to farm out an install. As a distributor, getting on this map is going to help you increase your sales from SimpliPhi products when people are looking to source batteries. And it's also going to show them that you know what you're doing as far as setting up, designing, and installing our systems. And ultimately, you want to encourage your installers to become involved, because the more installers you have on this map, the more SimpliPhi sales you're going to be getting. Ultimately, it takes about 2 minutes to apply, maybe 5 minutes. I may be exaggerating a bit there, but if you've got 5 minutes and you're already installing your batteries, this is a no-brainer. So just go ahead and apply, and we will see if we can get you through this process and onto our map to help you get some more business and promotion. So this is the link to apply. Now, I want to thank everybody for coming today, and I want to now jump into the FAQ section. And I want to remind you, if you need NABCEP credits, this is the email. Send me your full name and a request for NABCEP credits. And just say, hey, my name is blank and I want NABCEP credits, thanks. All right, I'm going to jump into the FAQ. This is my first training. Thanks for coming. Good to have you. If used for time of use, how does that impact battery life? So time of use is going to be really no different than any other use case here. It just is going to mean that you're using your battery daily for sure. And there's no problem with that at all. So you're going to want to make sure you fully charge, that battery during the cheapest hours of the day, and then you can use that power anytime. It's not going to shorten your battery lifespan. There's a 10-year warranty, and you can get approximately 10,000 cycles during those 10 years if you are cycling multiple times a day. But we do expect our batteries to last 10,000 cycles when used at 80% depth of discharge. Excuse me, just reading a longer question here. So someone's saying that they're seeing a bit of disagreement between their Victron BMV 712 and the Midnight Classic 150 charge controller as far as state of charge. So ultimately, I would trust the BMV 712 in this case because, like I said, it's a highly accurate monitor designed for lithium batteries. Now, the Midnight is going to go off of voltages. It's extremely accurate as well for charging. It's going to know when to stop charging your battery, and they're both going to kind of sync up at the top. So at the top of the charge, when the battery is full, they should both pretty much say 100% state of charge. Now, one might rise to 100 slightly faster than the other, and the other catches up, and then they sync up, and then kind of get off discharging. But they should always kind of sync up at the top. So hope that helps. If you have further questions, feel free to email me. Does the BMS allow you to check state of health of individual batteries? Great question. Short answer, the SimpliPhi batteries do allow this if you're using them with a solar inverter or another communicating inverter in the future, but the Phi batteries do not allow this. State of health is just kind of the generally slow deterioration of a battery over time. So maybe after 5 years, you've lost 5% of your capacity. The SimpliPhi is actually going to tell you how much capacity you have remaining. With the Phi batteries, you'd have to measure that another way. Does the Access need a cement platform? That's a good question. Most of our installations with the Access are on cement platforms. You can bolt it into cement. I believe that is the recommended. If you've got something other than cement and you need to know if that is allowable, email me and I'll figure it out for you. Question about how to balance several Phi batteries in parallel, making sure that you use the same size, as in same gauge, and then also same length cable. That's going to help the batteries to balance when both charging and discharging. There are so-called emergency inverters available with another company which can supply power with inverter connected to grid with blackout. Not too sure what you mean, but I think maybe you're talking about a UPS, uninterrupted power source. That's when the power from the grid goes out and immediately, without the blink of an eye, in milliseconds, your inverter switches over to battery power. So your appliances never even notice the power went out. That is something that you can do with our batteries, absolutely. You just need the right inverter. The amplified batteries are going to use an RJ45 cable for communications. Sunny Boy inverters have a special feature that will keep your home powered in a blackout for much less than the cost of a battery system. I'm wondering how that's possible, because if you don't have the grid on and you don't have batteries, where's that energy coming from? Would love some more details on how that inverter is magically generating power, because I would love one if that's the case. What brand 48-volt battery chargers are compatible? There's a whole bunch. Check out our integration guides. We have integration guides for several of the leading brands, let's say Victron, Schneider, Solarc, just to name 3. Are they compatible with SMA inverters? I'd say SMA inverters aren't the best to use with Phi batteries, but they do work, and we have seen them work. The reason they're not the best is because they run off of state of charge instead of voltage. Float charge only with a DC source, not with an AC source. Can you parallel a Phi battery with a different brand battery? Absolutely not. You should not parallel the Phi battery with any battery except the Phi battery. You can parallel a 3.5, which is our older model, or even a 3.4 with a 3.8 because they're just so dang similar, but you do not want to use a different brand because they could be using different cells. You do not want to parallel any 2 different batteries at all. And that's not just us. Every manufacturer says the same thing. What was the Victron battery monitor model? That's going to be a BMV 712 or 700. These slides are going to be available. They'll be emailed out to everybody. If you signed up for the webinar, you're going to get a copy of the slides. Do chicks dig SimpliPhi batteries? Absolutely. Absolutely. I just put up this background in my Zoom meetings with all the chicks, and they love it. Can you email me a NABCEP credit? Just shoot me an email. The email's right here. The BMS does passive balancing, and we detail that in a different training. Check out our BMS training on YouTube. Is it necessary to discharge the battery on occasion, say down to 20% state of charge? Nope. Not necessary at all. You're welcome to, but you do not need to. I'd say it's more necessary to fully charge the battery, on occasion up to 100% state of charge or 56 volts. That's where the balancing is going to occur. Any issues to consider with adding batteries to a bank over time as customers can afford or as needs change? The only consideration to be made there is the warranty of the newest battery reverts back to the warranty of the oldest battery in the system. So if you're installing a brand new battery on a 7-year-old system, that brand new battery is actually going to have a 3-year warranty left. So I wouldn't recommend that, but it can be done. We do have a Solar package that is hardened to withstand EMP. Gotta make a special request for that one though. I don't believe a lot of people are stocking it, but it is available. If each SimpliPhi battery has its own BMS, why is it necessary to match the cable length in parallel installs? It's necessary to match the cable length so that they all reach 56 volts at the same time. Essentially, the balancing is passive. It's not active. So you're not going to have one battery noticing, oh, I'm at 100%, but this battery's at 45. I've got to make sure to charge it. So you really want all the batteries to be charged in a very simple way, which is just you want the voltage between the power source and the batteries, the drop over that wire, to be very small and to be similar across all the batteries. We do plan to enable communications with the SimpliPhi batteries with as many inverters as we can get to over time. When would a battery combiner box be required? Check out our wiring guide on our website under our support tab. A combiner box would be best for very varying size of systems. I'd say maybe between 5 and 10 batteries. You'd want to use a combiner box. You can really use it anytime you want, whatever makes the wiring easiest for you to combine all those cables. Have you tested the BMV 700 and 702 with 5 batteries? I actually have not tested the 702, just the 700 and the 712, which, correct me if I'm wrong, those are the same thing except one has Bluetooth. Those both work great. I have not tried the 702. Make sure if you're getting the Victron BMV though, that it works in a 48 volt mode and it's not just a 12 or 24 volt BMV. I believe there's a couple different models. All right, everybody, that's all the questions. Thank you all for joining today. Have an awesome rest of your day and hope you enjoy this training.